here. Law of sines. You use when you have an angle and a side opposite it. Okay? So if you have an angle and a side opposite that angle that's given to you, you can use what's called the law of sines to figure everything else out. Okay? Remember, you have basically 6 parts to triangles, 3 angles and 3 sides. Now we're going to have 1 angle, 1 side, 2 angles, 1 side, or sorry, 2 sides, 1 angle, and you'll be able to figure out the other ones. So you're going to have to be given at least 3 parts to work with. Yes, sir?
Do you mean a side opposite of it?
Yeah, and the side opposite. I'm going to show you what that looks like here in a second. So, like we've done in the past, we label vertices with capital letters, and then the side opposite them are always what? Lowercase. So opposite A is little a, little b, and little c. So what will happen is we're going to use this law of sines when you can do this. If you have an angle and a side opposite. If you can circle the 2 straight across from one another like that, you're going to be able to use the law of sines. Now, like I said, the law of sines is nothing more than a ratio, which is just a bunch of fractions that are equal. And this is what it looks like. Take the sine of an angle is to its side opposite equals the sine of another angle to its side opposite, which equals the sine of another angle to its side opposite.
So they all mean the same thing?
Yes, sir. So what will happen is you might have information on A and little a, or you might have information on any one of those, and you can find the other parts depending upon what you're going to use. It is nothing more than fraction equal fraction over and over and over again. And if it's fraction equal fraction, how do you solve for x when you have fraction equal fraction? You just cross multiply. So what's going to look weird here is that you're going to be, instead of getting decimals all the time for, because if you press the sign of 32, it's going to give you some crummy decimal. You're just going to write everything out, and then you're going to create one giant messy fraction and put it in your calculator.
Gross.
Yeah, it's pretty much all it is. Okay, it's a bunch of gross stuff. No, sneeze. So let me show you how this is going to work. Start with an example like this. No, it's all breaking. It's breaking up. It's much better. It's so much better. You have there's like no pain in my sinuses. It's like drained out. It's almost over.
Where is it?
Yeah, it's just that last little bit. So we have a triangle ABC. You'll notice that you've got angles and sides and everything's drawn out. We'll put a little C there. And in this diagram, do you have an angle and its side opposite?
Yes.
Where?
B.
At B. So what we can do is this. Let me move this over a little bit. What we do is this. We start by circling that. The reason that I want to circle that is so that way I reuse that as my, I don't want to say, as my pivot, if you will. Something that will use it twice to solve for other parts. Okay? So since I have B, I can do this. The sine of B is to its side opposite, as the sine of A is to its side opposite. Since I don't know what the side is across from angle A, I'm going to call that little a. It's convenient how it works like this. So now I just fill in the blanks. So it gives me the sine 48 is to 28, as the sine of 35 is to A. That's just fraction equal fraction. Okay? Yeah. I mean, think of it this way. if it's fraction equal fraction, I could do this. 4/5 equals 12 over x. What would you do there? You can cross multiply. You'd get 5 times 12 equals 4x. And then what would you do to get the 4 by itself? I'm sorry, get the x by itself. You divide by the 4. And this would be your, what would equal x. Now, as a fraction like that, can't you just throw that right in the calculator with the fraction bar? Yeah. We're going to do the exact same thing, but instead of just pushing numbers, we're going to push the button that says sign as well. That's it. Here's what happens. When you cross multiply this, you get 28 times the sine of 35 is a times the sine of 48. You okay with that? Now, what I want you to, yeah, Kevin.
I'm sorry, I blanked for a second, but did we have 28 before?
Yes.
Okay.
Yep, that's the side opposite the 48.
Okay,
The
so then
A.
we just labeled that little b.
Yep. Excuse me.
So, would it be possible to figure out one of the signs and the tangent in your head?
You can do it in special right triangles, 30, 60, 90, 45, 45, 90. Those you will be doing in your head because you do that not do all the time. That's why we work on that a lot. But you don't want to. Okay. So now, how do I undo multiplying by some crummy decimal? Divide. Because the sign of 48 is just a crummy decimal. I don't care what it is. All I know is that it's a crummy decimal. So all of this junk right here is basically doing the exact same thing I did here with regular numbers. But all you have to do is press the button that says sign. So you use your calculator. Oops, I gotta turn that off. So when you get to do that, hit the fraction bar, and you quite literally type this in exactly the way you see it. And that's how this works. Okay? Eventually. I hate how long it takes this stupid software to load.
I got it.
You don't have a calculator, real?
I do, but I was going to show you guys what it's going to look like when you type it through.
We might mind for 15.
And I'm out of fun.
What's that?
Did you watch the Grammys?
Yeah.
They're really good. Kevin.
Did you see the top stuff?
Eventually this will work.
Should have started over.
It's thinking.
She was like, I didn't want to. Yeah, she was like, let's start over.
Oh, no, I didn't see that. I saw her sing this. It was like perfect.
Try this one.
How was your other son's birthday?
It was good. It was good. He wanted to have a Star Wars Force Awakens viewing party with his friends, so there were 8 second graders in my basement running around, not watching movies, hitting each other with everything they possibly could. So we hit all the Nerf guns. It was a smart idea. But no, it was a lot of fun. They had an absolute blast. So that's all. Have I mentioned how much I love the emulator software?
Yeah.
Seriously.
How does all
So guys, once again, when you get back to these things, make sure I don't think any of you guys have had any issues with that. Yes, sir.
This is off top, but isn't there an actor like named Ryan Murphy?
Yeah.
Okay, so I can remember.
I think he's the one that did. He's not an actor. He's a writer. He's the one that did.
I'm just gonna.
What's the name of the? What's that singing, dancing musical? High school, not High School Musical. It's the.
Hairspray.
No.
Glee. Yeah,
Glee.
Glee.
He wrote
American
Glee
Horror
and
Story.
American Horror Story. Yeah.
That's what he did. I've heard that.
Isn't Jeff Murphy an actor too?
Yes, he is. He's a famous actor. Did commercials.
Haha.
Some was by Spirit Video.
And he,
Dude, that was so funny. Oh my god.
Him.
So all you have to do is this. Put that in there exactly the way you see it. 28 sine 35 over sine 48, and hit enter. And that gives you the value of, what is that, little a. That's the side opposite, okay? So you get 21.61. And now I go back, guys. I go back then. Now I have this one at 2161. How do I figure out angle C? Should be the easiest part of all of this. How many degrees are in a triangle?
90.
As I rephrase the question, it might be one of the easiest things to find. It's 180 degrees. Subtract out the 48, subtract out the 35. What are you left with for angle C? You get 97. There's your angle C then. And now we do the same thing to find the side opposite C. We reuse our given. We're reusing that sine of b to little b, and we write it out. So what was it? Sine of 48 is to 28 as the sine, is it 97? Of 97 is to C. Yeah. Guys. Again, write it through. All right, figuratively like this. How do you undo multiply by crummy decimal? Divide by the crummy decimal. And yeah, you were saying there's a lot of writing out to this. There is, but the more you write it out, the easier it is. You can see what's going on, and it's quicker to write it out. Okay? Throw that in the calculator. You get crummy decimals.
37.39.
So 28 sine 97.
Show me now.
37.40 when you round it out to two decimal places. Now, unlike a right triangle, when you have law of sines, and eventually we'll talk about what's called law of cosines, there's really no way, bless you, there's really no way for us to be able to go back and double check our side lengths like you could with right triangles. In right triangles, you could always go back and check it with Pythagorean theorem. Here, you can't, because there's no way of knowing. So the only thing you can kind of do to see if you're on the right track is to check and see if, like, the largest angle has the longest side length, the shortest angle, the shortest side length, things like that. If that holds true, you're probably on the right track. It's just it's one of these things that you kind of have to take it with a grain of salt that you know that you're on the right track and hope for the best. So that's how that works. Not so bad, is it? Yes, sir. And this is where, I've always keep saying reuse given information. If you don't reuse some of your given information here, if you don't reuse that 4828 and you go to that 2161, since you've already abbreviated the 61, as you go to the next one, it'll be off a little bit more. That's why I kept getting you guys try to continually reuse given information, so that way, in the long run, you're not going to be off by those thousandths and stuff like that. And that's kind of what it works out to be. Right. Let's try another one. Oh no!
Oh, no picture.
There's no picture.
We can't draw it.
I think you could probably draw a triangle. I have faith in you, as little as it may be. Yes, sir. I have faith in you, as little as it might be, to be able to draw a triangle.
Good.
I fully like hate you.
Good.
Humans are so bipolar with each other.
I have never played with.
Good.
What's that?
Everyone
Good.
Yeah. And you pick up on that right away. So what you want to do is draw out what you have.
Angle B 17. Angle C.
Label it out. So we have 46,
We don't have A.
Yeah. Mr. Murphy.
18,
C.
17. You need a little b and a little a. Now, once again, how many degrees are in a triangle? 180. If I back out the 17 and the 46, what am I left over with then for angle A?
It says define
Solve.
Solve the triangle.
Solve the riddle. Puzzle.
So how many degrees are left for angle A? Good. Bless you. So we know right off the bat, whenever you're given two angles, finding that third angle is relatively easy. Okay? Just subtract it out from 180. Now, what information were we given in terms of both sides and angles that were opposite one another? C. Okay, bueno. Circle it. I'm going to use that as my standard, my pivot, if you will. And when I use that, I write it out. The sine of C is the its side opposite. The sine of B is the its side opposite. Now, does it matter if I find side A or side B first?
No.
Nope, doesn't matter, because you're still going to reuse that the C stuff as you're going through it. Okay. So now you know that this is the setup you're going to use. Fill in the blanks. So we have the sine of 46 is to 18, as the sine of 17 is to little b. We okay with me on that?
Wait, is
Cross, multiply, and rewrite. Was it? No, it was
46.
46. The first one, I think we had 40 on the first one.
Yeah, we have 40 in.
And then this one would be sine of this equals, what, b sine of 46. Oh, that brings up a good point. There was a couple of times where people wrote down the wrong number in the problem in their trig functions, if that makes sense. Let's say you accidentally wrote down, it was a 46 again, but you used 48. But you wrote everything out, you got everything right by using 48s. I didn't mark you wrong, because you did everything right, you just wrote down the wrong digit. Bless you. There were people that wrote it down, they, I think there was a side link, there's one side link that they accidentally, their handwriting got the best of them, and they turned something into a different number. And all of a sudden a 6 became an 8. I think that happened. And they did all the work right. There was nothing wrong with it, they just had really bad handwriting. So I didn't mark it wrong. So that's the idea. The more that you show what you're going to do before doing it, the better off you will be. When you threw this in the calculator, what'd you guys get?
7.31.
Okay.
7.32.
What is it? What's the decimal? 731.
6.
Yeah, so it'll be 732.
Oh, okay.
Okay. That gives you the side B. And then we do it again for A. And that gets you the next one. You're just rewriting your steps out. Okay? You're just rewriting your steps out to show what you're working on. They asked in first hour about why we actually go through and show you guys how to set these things up. Using law of sines and eventually law of cosines is something that you can use really anywhere. There's a lot of like surveying things that you can do. You can measure, it's very easy to measure out distances, even if you don't have right triangles, if you know how to find an angle within certain values and stuff. So what do you get for this one then? 21.58, and you're getting what?
I
did not get that.
I
All right, let's see here.
56.96.
I got 22.9.
Let's see here. 18 sine 117 over sine 46 and hit enter.
That's why I did 46.
Hey, that's what I got.
117.
There
That's
you
what I
go.
got. I'm
So
sorry.
22.3.
Yeah.
Oh, I feel like this is 17. See, I did,
I
I
was
got
17.
117.
Gotcha.
It's 117.
And that's the idea. You got to be very careful on how you type it through. And once again, as you go back to look at the triangle itself, it's there's really no way of being able to verify if your solutions are correct or not. But all you can do is kind of look at the approximations. Do you have the big angle across from the larger side and things like that? We have that work. Okay. All right. Another version of this is sometimes you have to find the angle. Okay. Let me show you how that one's going to work. This one. Fine. Complain. So this is a different way of having to do this. So far, what I've shown you guys is finding side lengths. Now we have to show you guys a way of setting up to find an angle. Now, think about when you did right triangle trig. When you had to find an angle with right triangle trig, what buttons did you have to press? If you didn't know the angle.
Also, it's just inverse here?
The inverse, right. So when we did that with right triangles, we had stuff that looked like this, where you had, well, obviously a right angle. You had theta, and let's say this was 13 and this was 17. Well, you would write out then that, well, this is the opposite. So you'd say that the sine of theta was 13 over 17, right? And then you'd inverse it, you'd write it as theta was the inverse sine of this fraction. Now, do you agree or disagree that 13 over 17 is just a crummy decimal, but it's just written as a fraction?
Yeah.
Okay. Now watch what happens when you do this. Do we have a pivot?
Yes.
Okay. What angle is it forcing you to find first? B. It's forcing you to find angle B because we have side B opposite. So you write it out. The sine of 33 is to 27. Sine of the angle, side opposite, is the sine of B to 40. Now I'm going to show you guys a little shortcut from this side. Is our variable in this case in the numerator or the denominator of the fraction? It's in the numerator because it's trying to find the angle.
Wait, what?
So if I just worry about this, if I cover up the sign real quick, how do you undo divide by 40? Multiply. So here's what you want to do. Anytime you're trying to find the angle, just multiply by the denominator to the other side first and write it 40 equals the sine of angle B. Hey, isn't that the same thing as sine of an angle is some fraction? Sine of an angle is some fraction. It just so happens that that fraction has the word sine in it, which means you're just going to put it in the calculator with a button press. So now what happens is this. What I want you guys to get accustomed to doing is typing stuff in the calculator and letting it do all the rounding stuff for you. Make your fraction bar. 40 sine 33 over 27 and hit enter. So that means that the sine of angle B equals this crummy decimal. I need to inverse sine that now. Very easy. Second sine of your answer. There's your angle.
Wait, so what?
How do you
So what do we put in here?
What's that?
How do you do of your answer?
Yes.
Second answer. It's down at the bottom by the negative symbol. Yeah. And that's, we're going to use this all the time for this stuff. Whenever we're finding angles, we're going to hit that inverse, we hit the second sign of the answer. You don't have to. Not for that. Okay. The reason why I put a lot of parentheses to close stuff up is that when we get to cosines, you got to be careful where your parentheses go because it could be pretty. If you don't type it in correctly in the calculator, it can be off, like way off. Okay. So that's how I get that angle, 53.79.
Is there anything underneath side B?
No, what we did was we got rid of this by moving it up here. We multiplied just by the 40. Instead of taking the long way around, we could have done, what was it, sine 33 over 27, sine of b over 40. You could have cross multiplied right away and done 40 sine 33 equals 27 sine of b, and then divided by the 27 to bring it back. But it was already there to start with. That's why we don't bother bringing it up and bringing it back. Because it just saves you a step. Now, this is your angle here, 53.79. And I know that I've always said, try not to reuse your givens. Sometimes you have to. This will be a case that you will have to reuse that what you just found to get the next angle. So just cross your fingers that you got it right. How many degrees are in a triangle?
180.
I thought it was 360.
And if you subtract those two angles out, what do you get? 93.21. And now I use that to find the little c. Okay. Now I use that to find the little c. They move this up. And now, since my variable has gone back to the denominator, I actually do want to rewrite out my whole cross multiply part. What's that? So we have 27 sine of 93.21. And you're just dividing out by a bunch of nasty looking decimals. Okay? That's really all it works out to be. Okay? What do you get when you do that then? $49.50?
Yeah.
Okay, you have 49.50. Go from there. And once again, there's really no easy way to tell whether or not you're right, except that you can double check to see if your sides match out. Yes, sir?
So the inverse is when they give you the side but not the inverse.
Correct. Inverses are always used for finding angles. Okay, inverses are always for finding angles. Go for it. Solve the triangle. For time-wise here, what is it forcing you to find first?
R.
Q.
But you have R.
I use it for money.
Go through that. Cross multiply through, all you have to do is bring the 12 over. Which means you have to dump right to the calculator. Make your fraction bar. 12 sine 16 over 11. Hit enter. That crummy decimal equals the sine of angle Q. To get the angle Q, then you just hit second sine of your answer. 17.50. Okay. That gets me to here. So that's what, 33 and a half, subtract that from 140. And then I use that to find a little p. Mm-hmm. Cross multiply through. It's really important that you write out what you're doing before you do it. $22.03. Anybody else get that?
Yeah.
You round up?
Yeah.
Yeah, you go to the third digit. Always go to the third one and see if it's 5 or up, and you go up from there. Okay? Law of science?
This is easy.
Everyone stop clapping. This won't work.
Good job, guys.
Hey, I've got it. You're not going to do all of these, so don't worry about it. I'll tell you once there's a second. Yeah, for them.
There's no room.
Yeah, use a separate sheet of paper.
Thanks.
Yeah, there's no room on this. Just use a separate sheet of paper. I will tell you which one's here in a second. Excuse me. Guys.
Almost there, bro. No more school. Oh, it's not before, but no more like regular.
Now I believe I think the first two just are asking, thank you, sir, are just asking for a specific one part. The last 5 are where you're solve out all the parts. Yeah.
If you don't have room, can you like staple
That's what I'm saying, right, yeah, do it all on a separate sheet of paper, that way you have more room, okay?
SG side. Oh,
Study guide, Dan, I was gonna say page 47, but they're both page 47. Like number 3 and 4, that's what I meant. You see how it just says solve for, find R, find little s. So that means you only have to find one part. But on the other one it says solve the triangle. That means you can find all the parts. Also, it says 10. What should you do? 100. Yeah, always go to the 100, okay? Excuse me.
If we can't,
Don't. Just use a separate sheet of paper. Tomorrow what we'll do is we're going to go into a little bit of the cosine stuff. And with the cosine stuff, you have to then use the law of sine stuff. So it's kind of awkward how it works. And there's also a bunch of other rules that happen with this stuff as well. I don't know if we'll get into it or not, but...
Well,